Hello everyone. Today now we will take the logarithmic function to one step ahead, and we will apply um, derivative to implicit functions. That is, we will learn how to differentiate implicit functions. The method of differentiating implicit functions and logarithmic functions will be somewhat the same, because even in implicit functions we can have powers in the variables in the powers as well. Okay, so let's first learn what do you understand by implicit function. It says, I want you to copy this, by the way. If fx comma y equals to, that means if a function of x comma y is there such that y cannot be directly expressed as a function of x, then the function is called an implicit function. It means, let me show you first an example is given here, though another example I'll show you. Suppose x plus y equals to 1. What do you see here? I can directly write y equals to 1 minus x, isn't it? So y can be expressed in terms of x. This is not an implicit function. Okay, so if you can separate x and y to be let's say in an informal way, I can put it that way. If I can separate x and y, then it is not called an implicit function, because here y can be expressed in terms of x, will be 1 minus x, and x also can be written as 1 minus y, isn't it? So these are not implicit functions. Implicit functions are such functions, according to the definition, where y cannot be directly expressed as a function of x. Let's have a look at this one here. You cannot separate x and y. Check this out. X is here and x square and y are attached with one another, and y cube is here. Even if you try, let me show you. 3x square y plus y cube equals to a cube minus x cube. Even if you try, you cannot separate x and y. From here, if you take out y common, then you will get 3x square plus y square equals to a cube minus x cube. Did you see that y cannot be completely taken out? Check here. There is a y here, there is a y left over here. Even if this y, suppose, even let me put it this way. Even if this variable goes down, this expression goes down, then what do you get? Y will be a cube minus x cube divided by 3x square plus y square, isn't it? There is still y square on the other side, so y cannot be completely separated. Here is a y, there is a y here as well. So such a function is called a implicit function, where you cannot completely separate x and y. Let me show you another example, something like this. X square plus xy plus y square equals to 5. This is also a implicit function. Why? Because here you cannot separate x and y. Let me show you again. Xy plus y square equals to 5 minus x square. If you want to make y as the subject, y will be common. X plus, there is one more y left over here. Did you see that? So even if you take this expression down, y will be 5 minus x square divided by x plus y, and you see there is a y on the left, there is a y on the right. So y is not completely separated. You cannot completely make y in terms of x. So such a function is called a implicit function. Okay, so differentiation of implicit function is not so difficult. If you know logarithmic function, 50% of your problem is solved. And for some other implicit functions where you don't have to apply logarithms, it is quite simple. Okay, so next we'll learn how to differentiate it. Okay, the first sum that we are differentiating under implicit function is x cube plus 3x square y plus y cube equals to a cube. Okay, let's start. So how would you do it? Differentiating both sides with respect to x, correct? Okay, so I apply the operator. D dx of x cube plus 3x square y plus y cube equals to d dx of x a cube, correct? Okay, now d dx of x cube, let's distribute if you want. D dx of x cube first, plus 3 out, d dx of x square y plus d dx of y cube, and this side d dx of a cube, correct? By the way, a is a constant. What is a, everyone? Constant. And d dx of a constant is 0. Remember that. So what is d dx of x cube? First part, 3x square, applying the formula. Because d dx of x to the power n is n x to the power n minus 1. You know this. And here now I need to apply, check this out, I'll highlight, I need to apply product rule, because x square and y is being multiplied. So 3, and then I'll get second, that is y into d dx of x square, plus first, that's x square into d dx of y, correct? plus, now what is ddx of y cube? If you remember, in the last class I had explained this in the previous videos. ddx of log y, if you remember, it was 1 by y dy by dx. Whenever you differentiate anything in terms of y, dy dx will be followed, isn't it? So what is ddx of y cube? Same like x cube, that will be 3y square, but followed by dy by dx. Remember that, correct? And finally ddx of a cube, 0. Don't write 3a to the power 2 etc and all, because a is a constant. You just write 0, simple, correct? Okay, by the way, I see some of you have been doing this also. Some of you, what is ddx of 3x? Simple, 3 comes out, ddx of x is 1. What are you doing? Some of you are applying product rule even here. You need not do that. If there is a constant, just pull it out. That's enough. Okay, I have seen this in some of the sums that you have solved earlier. Okay, now let's come to the sum. So you get 3x square plus 3 open bracket. What is ddx of x square? 2x and the leftover y, plus what is ddx of y? That's dy by dx. So x square dy by dx. Remember, ddx of y is dy by dx. ddx of y square is 2y dy by dx. ddx of y cube is 3y square. Let me write here, y square, ddx of y square is 2y like x square, but again followed by dy by dx. And ddx of y cube, we have seen it here. Here it is, where is it? Here, 3y square dy by dx. Let me highlight it here. Okay, now plus 3y square dy by dx. Okay, so I need to find the value of dy by dx, because differentiate means find dy by dx, isn't it? So what do? I'll separate everything. 3x square plus 3 to 6 xy plus 3x square dy by dx by breaking the bracket, plus 3y square dy by dx. Let's bring together dy by dx. Okay, let me do it here. I'll rub all of these here. Okay, okay, I have some more space. So 3x square dy by dx along with 3y square dy by dx is together. And what do I have here is that side minus 3x square minus 6xy. So everything goes to the other side here. The one with dy dx remains on the left, the one without dy dx goes to the right. So what can I do here is, now dy by dx common on the left, and I get 3x square plus 3y square, correct? And that side I have minus 3x square minus 6xy, correct? Okay, now dy by dx equals to minus, okay, I can take minus 3 common. I'll get x square plus 2xy. Can I do that? And divided by 3 common, x square plus y square, because this moves down here, correct? 3 and 3 gets cancelled. So what is dy by dx ultimately? Minus x square plus 2xy divided by x square plus y square. Ultimately my objective was to find dy by dx. So even if I get 2 dy by dx, there was a dy dx here and there was a dy dx here as well. So what did I do? I grouped them together and finally took it common and found the ultimate value of dy by dx. So that's how we handle implicit functions. In implicit functions, you see that x and y are mixed together. So you might get many dy by dx, but that way again you will bring together the dy dx, take common and find the value of 1 dy by dx ultimately. Okay. Okay, the second one is rather interesting now. Why? Because it looks something like logarithmic differentiation as well as implicit, isn't it, everyone? Check this out. There's a y here, there's a y in the power as well. So this tells me that I have to use log, because if there is variable in the base, variable in the power, I need to use logarithmic differentiation, isn't it? So what I do here, this is a combination of actually logarithmic as well as implicit. So in this sum, I will have to apply the concept of logarithmic differentiation first, and maybe later see how many dy dx we will get. Okay, so what do I do first? Taking log both sides, okay, because there is a variable in the power, variable in the base, variable in the power, correct? So what do I get? Log y equals to log x to the power y. By the way, if you want the direct formula, you can use that as well. So this gives me log y equals to y log x, applying the power law because the power comes in the front. Okay, now differentiating both sides with respect to x. Time to differentiate. What do you get? ddx of log y equals to ddx of y log x, correct? Okay, that gives me 1 by y dy by dx. If you remember, dx of log y, okay, like normal x followed by dy by dx. Here I'll have to apply product law because y and log x is being multiplied together. So second, it's log x into ddx of first means y, plus first into ddx of second means log x, correct? Okay, quite simple. So 1 by y dy by dx ultimately equals to log x dy by dx. So I'm getting 2 dy by dx plus y, and what is ddx of log x? 1 by x. So that becomes this. Okay, so 1 by y dy by dx, and let's move this dy by dx to the other side, minus log x dy by dx equals to y by x ultimately, correct? Finally dy by dx common, and I get 1 by y minus log x, correct, equals to y by x. Okay, ultimately let me do it here. So it will be dy by dx. Dy by dx will be y by x divided by 1 by y minus log x. Let's simplify this a little. So that gives me x here, y up, and what's the LCM down? Y. I'll get here 1 minus y log x. Okay, how do you mix it up? This moves here and extreme moves to extreme. So that gives me y square x 1 minus y log x. So that's the value of dy by dx ultimately. So did you understand? Check this out. What did I do? I applied logarithmic differentiation first. I applied log both sides because I see there was a variable, yes, in the power, as well as there was a variable in the base as well. Got it? So that's how we solve some of the implicit sums. So this was a combination of implicit as well as logarithmic. How? Why implicit? Because y cannot be completely written in terms of x. That's why we can say this is implicit as well. If you have understood the concept of logarithmic differentiation properly, this would be very easy to understand. Okay, so by the way, before doing this sum, let me remind you, if you haven't understood logarithmic differentiation, please take your time to understand it, practice properly, redo the same sums again and again. I know it is quite tricky, logarithmic differentiation. Only after that you will be able to understand implicit differentiation. Okay, so let's go to the third one here. So it says if e to the power x plus y equals to xy, so that dy dx is y 1 minus x, x y minus 1. Okay, so if you want, you can use logarithmic differentiation here as well. Okay, because you see that e is also a function of x and x plus y is also a variable in the power as well, isn't it everyone? You see variables in the power, so you may use logarithmic differentiation. Moreover, multiplication will also become simple when you use logarithmic differentiation, isn't it everyone? Okay, but if you don't want to use log differentiation, that's okay. So let me show you a little first. So how would you do it without using logarithmic differentiation? Correct? So differentiating both sides with respect to x. Check this out. I'll get ddx of e to the power x plus y equals to ddx of xy. Correct? E to the power x plus y chain rule, because I know the formula of ddx of e to the power x. Imagine this is x. So what is ddx of x, e to the power x? E to the power x plus y, and again chain rule, ddx of x plus y, correct, equals to product second ddx of first plus first ddx of second. What did I apply? Product law. That gives me e to the power x plus y here, and then this is 1 plus dy by dx, and ultimately here I get y plus x dy by dx. Correct everyone? So let's mix it up. E to the power x plus y into 1 is e to the power x plus y, e to the power x plus y, as well as dy by dx. How did you get that? This multiplies inside, it goes here, and here y plus x dy by dx. Correct? Okay. Now e to the power x plus y minus y, this moves towards this side, and that side I'll get x dy by dx minus e to the power x plus y dy by dx. What happened? This moved to the other side. Then e to the power x plus y minus y, here dy dx common, and I get x minus e to the power x plus y. Correct? Check this out. Okay, great. Now what will I get ultimately is e to the power x plus y minus y, and this moves down now here, whole divided by x minus e to the power x plus y equals to dy by dx. Ultimately I got that, but this is nowhere close to the answer. Check this out. This was my dy dx. I'm getting something in terms of e. So can I replace, instead of e to the power x plus y, I can write xy, because e to the power x plus y is equal to xy. So I'll replace this by xy minus y divided by x minus xy equals to dy by dx. So here y common, x minus 1, and here x common, 1 minus y equals to dy by dx. But what did you observe? Check, this is just the opposite, isn't it, everyone? There was a 1 minus x, so that's okay. You can take common here. Minus common, y, 1 minus x, it flips. And minus common x, y minus 1. So minus minus cancels. So that's dy by dx. You know, when you take out minus common from a minus b or x minus 1, it gets flipped. So that's it. So isn't it the same, everyone? So this is how we prove dy dx equals to y 1 minus x and x y minus 1 without using logarithm. Now I will do the same sum by using logarithm as well. You just see which one is easier. Okay, you may copy both. Okay, let me rub this first. Okay, alternatively now, okay, I'm to use logarithms now, isn't it? Okay, so e to the power x plus y was equals to xy. Let's use log. Using log both sides, log e to the power x plus y equals to log xy. Why could I use log? Because e is also a function of x, remember that. Okay, so in exponential you can use log, that's not a problem. So I will get power law, this will come right in front, x plus y log e, okay, equals to log, what is the formula? A into b will be log a plus log b. So that, sorry, not log a, log x plus log y, because if the subject is multiplied you can write plus, log property, product law, correct? Log e means 1. Check the logarithm formula, because the base is also e, and same base same subject, it will be 1. So log x plus log y, correct, everyone? Check this out. So finally I have this. Now differentiate. So differentiating both sides with respect to x, what do you get? D dx of x plus y equals to d dx of log x plus log y, correct? Let's differentiate. What is d dx of x? I'll write here 1. What is d dx of y? Y here. So I'll get dy by dx. That side, d dx of log x is 1 by x, d dx of log y is 1 by y, dy by dx. So ultimately 1 minus 1 by x, this comes here, equals to 1 by y dy by dx minus dy by dx. So LCM is x, 1x minus 1, sorry, and that side dy dx common, I'll get 1 by y minus 1. So here x minus 1 by x, show here, equals to dy dx, what's the LCM? Y 1 minus y, correct? So y x minus 1 divided by x 1 minus y equals to dy by dx. Now you may say, how come this moves down, this goes up? Crisscross, cross multiply. Is this what you have to prove? Check this out. Okay, just the opposite, like in the previous case, it's x minus 1. So take minus common y 1 minus x, and minus common x y minus 1 equals to dy by dx, and cancel. So that's it. So whichever is easier. I feel logarithm, using logarithm will be much more easier than without using logarithm. So did you understand? So this is how we solve some implicit sums. So this much for today. This is what I have from implicit functions. Some homeworks are given below, homework sums. Please try to solve it. Please remember, I'm telling you again, boys, please focus more on logarithmic differentiation and chain rule. Chain rule and logarithmic differentiation is very, very important. It will help you in further more topics to come as well. Okay, so thank you.